Welcome to our video series focusing on the role of data platforms and IT/OT convergence in industrial environments. I'm David Ariens, and today I'm joined by Bert Baeck, an absolute authority in this area. And if you're involved in industrial operations, maybe as an operation manager, looking to your daily production report, or as an energy or sustainability manager, looking back to past energy usage, maybe you're a data scientist predicting upcoming failures or the quality of a product, then you rely on accurate data. So the data journey starts at sensor level, where we have temperature sensors, flows, kilowatt-hour meters, you name it. But the actual question is, can you rely on that final report, that dashboard, that AI model? Because data moves and morphs from one system into another before it finally arrives in your inbox, on your smartphone, maybe on your SCADA system. And it's vital that every number, every KPI, every graph is not just data, but a trustworthy metric. So how do we ensure that reliability? And this is where data quality comes in, making sure that you know that what you see is accurate. So join us today as we do a deep dive in this subject with Bert Baeck, CEO of Timeseer, and discover our strategies to ensure data integrity in your industrial processes. Thank you for joining us.
Welcome. Thank you for inviting me here.
So so you've been in this industry for quite a while. Maybe a short introduction from your side, your experiences.
Yeah. So indeed, I've been running in this industry for more than a decade. So I'm Bert. I was the former founder and CEO of TrendMiner. I started my career at Covestro, early buyer in the industrial automation, and there I fell in love with the topic of in the ability or the potential of data analytics quite early on. We speak 2007. I decided to do something with it together with a couple of former students on the university, and that company became TrendMiner. TrendMiner is like two kind of parts. The first was very hard, too early, not really solving a pain. It was a financial situation in 2008. We were inexperienced, like green behind the ears. But we failed forward. We learned a lot. We spoke with a lot of prospects. And I think in 2015, we were really ready for the transformation. And that part became TrendMiner. So we rebaptized the company from D-Square to TrendMiner. And that became a success. I think that company was acquired by Software AG in 2018. And by that moment, half of the chemical industry, the top 50, were clients of TrendMiner. And there was really an interesting pressure and battle going on with Seek. And I think that kept us sharp. And I really look positive towards that experience. But after the integration with Software AG, I left quite soon. And I had the opportunity to join Smartfin Capital as a partner, which is a leading European venture capital firm with close to 600 million euros assets under management, so money to invest in startups and scale-ups. And I was there to do the industrial ML, IoT, analytics, and there I had a lot of time and talking to startups in the ecosystem, and that is basically the part before I left and I started Timeseer. A bit more about that in a second.
Amazing. It's also fun because our paths crossed several times. We crossed in the D-Square time, we crossed in the TrendMiner time, and now we cross again in the Timeseer time. So it's really cool. Yeah. Maybe to start, why is data quality important to you? What triggered you to found Timeseer? Yeah,
there is two answers on that. There's to me, and there's of course to the market. Let's start with the market, right? So why is quality important? I think if you look where we are in time and with technology and like with data, we came originally from data collection, putting a lot of data in like historians and data warehouses, and we jumped right away to analytics. We did the same with TrendMiner. But what you see now is that a couple of things evolved. So first, we are now able to store data at scale, like in the cloud, wherever, whatever. We also can compute data at scale. That's like the wave of big data that's behind us. So it's all check the box. And this is exactly the moment in time where companies start to build data-driven applications. So they start to rely on their data, they start to build data products, they use the insights, they do the root cause analysis on the top of the data, and they run machine learning models to predict like failures, they act upon it. And that's also what I call then the great unlock. Store, compute, and then build applications, the moment in time where the quality of data really starts to matter. And that is now. And if the quality is mattering for the right reason, that's also revealing why this quadrant or this topic suddenly is important again. And to be honest, it's an old category. If you see, like, with all respect, companies like Informatica, Talent, Precisely, super profitable companies with EBITDAs of like 50%, they are already there from in the 80s, and like data quality has been around for many years, but not mainstream. And today I think, and it's more like a prediction, it's really becoming mainstream. That's one thing. Another prediction, data quality at maximum was a feature within analytics. It's moving out of the analytics stack. It's moving into the middleware, moving into the architecture, where companies really are building one single version of the truth. And that is also why I got interested in data quality, the opportunity. And what we see is like with thought leaders like Andrew and G saying, yeah, we don't need better models, we need better data. That's really the reason and the why behind this company. And having with this founding team a lot of experience in time series data, we decided like we have to do this. We are capable of doing it. We have the background, and we know how important quality is and becoming. And it was like not popular, unforgotten domain for quite some years, but now it's really blocking analytics, and it's keeping organizations away from taking that next step in AI maturity. And that is basically why I'm here in this market again, and why I decided to jump back in the trenches as a second-time entrepreneur with the team.
I saw this interesting meme of somebody, I think, working for Tesla. He said, while I was doing my PhD, I was working on 85% of my time I was working on model developments. And while I'm working for Tesla, I'm working 85% of my time in collecting data.
Yeah.
Which is a total mind shift. So could you maybe with that meme or that example in mind, why is data quality important for people who use data on a daily basis? And I think that's almost everybody today.
Yeah, that's a good question. I think we have to distinguish a couple of things. Not everybody is as aware with respect of data quality. To give an example, people who are already working with sensor data, for example, or with OT, IoT data on a data level, yes, they acknowledge it's a problem, and they will spend up to 60% sometimes of their time pre-processing, cleansing, transformating the data. And that's a big problem because data scientists are a scarce resource. They are not really cheap or expensive to business. And then losing their time on something they do not scalable at the end of the data pipeline, that's a waste of time. That's also an opportunity cost, because if they could spend more time on debottlenecking models and building more AI for production facilities, for example, that would really be beneficial for all sides. So that's more like on a personal level. But then there's an even more bigger threat for me personally, is that CDOs, chief data officer, chief digitalization officers, they're creating like budget for their organizations to become data literate. Like, hey, everybody needs to do more with data. But the brutal truth there is that I see too many people today consuming data on a daily basis, or consuming dashboards, relying on it, where the data quality can't be guaranteed, and that's really a liability. So the transformation there is, if all these companies start to yell like, hey, data is a new oil, it's an asset, well, they have to be careful, because if the data can't be guaranteed for quality and governed, data becomes a liability, and that is that's also part of our mission.
There's a fun story where I used to be a data scientist in my previous life, and we were responsible for environmental reporting, emission reporting, and I still remember very well that what we actually did is every year in the month of January or February, we basically started our yearly exercise.
Yeah.
So we started pulling in data from all these measurements of the last year. And what we basically figured out was data gaps, spiky data, noisy data, for example, quality sensors who are just drifting away.
Yeah.
And what we really needed to do is we needed to start implementing replacement values, and we needed to sometimes even pay fines, I guess, because you need to be measuring accurately. So with that example in mind, you gave a couple of examples yourself, my example. So at a certain point in time, you decided to start Timeseer. What were the first things you did, or how did you embark on that journey?
Well, I think the first part is there indeed what a very important thing when you talk or address OT, IoT data is something to think about also for the audience, is for operations, if we address operations, right? Data good enough for operations is not per se good enough for analytics. And I think there it's all started by means, if you're running a plant, running your operations, there's a control system, there's an alarm system, there's a safety systems, there's a human in the loop sitting in front of the screen. So there's a lot of safety nets. So data can flow in and it maybe can be bad, or I cannot trust the sensor, or it needs to be calibrated, or I see gaps, but the plant keeps running. So data quality is not always per se for operations a big problem. It can rely to problems there we have evidence from, like unsafe situations or like causing downtime, but it's not per se always a problem. But then we move forward. That data gets stored somewhere in a data historian or in a cloud warehouse, or it's moved from the OT to the IT level. And if your quality there is not guaranteed or good enough, it sticks. It sticks forever. And that is indeed what you say, like with like emission reporting. The people that need to take that data and use them for that report, they are cleaning and cleansing like post effects, after the effects, and they can spend time on it. But this is not per se a problem of operations, and that it's really shifting because with data products, with data product owners, with data stewards, you will see a whole innovation and all like a new wave coming where the responsibility of the quality will be shared. Data quality is not per se the problem of IT, but it's not, because in the IT domains, they don't always understand that sensor data. Like that's also why data scientists, for example, spend a lot of time on cleansing and contextualization, calling the factory by saying, what was the problem with that moment? Yeah, we had a maintenance event. Yeah. That's all after the effects. And what you will see happening is that this after the effect, is moving from reactive to proactive. That's the first part of your question. The second is basically how do you start? There is, of course, you need to solve a business pain. And we had a lot of evidence by scanning repositories of clients that the concept that we call data defects, data downtime, that's not a KPI on board level, but it will become one, is that we had a lot of visual and like evidence that data downtime really was causing problems in data products, indeed for a data scientist in his daily journey, but also indeed, yes, in operations, where indeed, for example, analyzers from a factory were used for billing. Billing was completely wrong. Well, that's a problem. Like factory A is delivering material, factory B is consuming it. They had wrong readings for the same measurements, data arbitrage. So you see a lot of use case popping up where that data is used for analytics, for billing, for digital twins, for data sharing, for moving your business model to as a service. So you see today a lot of use cases using data that are really blocked, and the data needs to be good enough to unlock them. That is also how we started, is by showing our clients, prospects, how vulnerable they were for data quality in their daily operations.
Yeah, and I mentioned in the introduction, we talk about data platforms. We talk about typically OT data platforms, really tailor-made for sensor data. We talk about IT data platforms, tailor-made for, I would say, more relational data flowing in from ERP systems and so on. Is data quality, is it a similar problem on both sides, or are there differences?
It's a very good question, because it's not. And that's also a link again to why we started Timeseer, is by observing back in 2019 a lot of opportunities that resonated data quality. There was a lot of companies that started then on data quality platforms that 100% focus on relational data. Relational data, there's a couple of things. A lot of times it's already landed in a data warehouse, cloud, like Snowflake, Databricks. There's the logs of the system, the lineage is clear, it has a data model, it's SQL centric, and everything I just said is all different on the OT, IoT side. Like with sensors, you often miss a baseline or what's normal. There's a different data model. The connectivity for OT is completely different. There's a different lineage. It's a lot of the time still residing on the edge or in the historian, not always in the cloud. So and then there's also the nature of time series data, which is completely different than relational data. That's also why we identified a gap like, hey, this OT, IoT data quality is something completely different than relational data. So that needs to be addressed. So that's part our interest to start Timeseer. And then there's also that very important thing, very simple data quality things like volume. Is the data volume the same? Freshness it's coming in. Very simple things to check. But fundamental when you talk sensors, OT devices, IoT devices, more complex things like, can I trust this reading of the sensor? Is it representing the state of the process of the operations? Other things like, is that sensor needs to be calibrated? Is it have configuration errors after maintenance event? Is it, for example, aging? Is it a little bit fouling? Do you have placement issues? That are all things that are not existing on the IT SQL-centric data quality side, and that is why that sensor OT-specific layer in Timeseer is the heart of what we're building and necessary.
In your logo, in your name, your name Timeseer.ai. So I assume that is because you, I would say, enable further AI developments, but I also assume that it's because you're using clever algorithms within your own product. I've seen many people, I would say, building quality checks themselves.
Yeah.
Is that something where you see that as well? Why do you think Timeseer can be a very valuable add-on or maybe even replacement of those more custom-built solutions?
Yeah. So if we look at what you just said, AI needs data quality, first part. But data quality also needs AI. That's a little bit what you're saying. For a couple of reasons. Is when you work with massive sensor data, there are a couple of what I would say barriers or really big challenges, and they are related to following aspects. One is, for example, scalability. Yes, you can do some checks for a couple of 100 measurements and it will work. But what if you have like millions of sensors globally, you need to do it for all your plants on a central kind of level? Very difficult. That scale part, especially if it needs to go fast enough. Robustness. Maybe it can work now, but what if your system evolves, your operations changes, new sensors pop up? Robustness is a very important challenge also if you would build something yourself. Another one is, for example, accuracy. That's a big problem because if you don't apply some smart, sophisticated algorithms based on AI for handling the time series data, you will have a rain shower of false alerts. And remember the good old times when we talked about alarm management, it was about nuisance alarms, false alarms. Well, the same is happening with data quality. If you have an avalanche of false alarms with respect of data quality, that's really a problem. So you need to go from big data to small data, but also for respect of making data quality biteable, manageable. That respect is getting to the right insights, but just not too much, because if too much information, nobody will look at your system. So accuracy, scalability, precision, robustness, and that is all things if you would do it yourself, build it yourself, there are things that really goes far in your journey, and we see like that's a challenge for the building teams. So that is a little bit what we see in our journey building Timeseer.
You mentioned data stewards or data owners or platform owners and so on. How do you make their job easier with Timeseer?
Yeah, so to be honest, I don't see a lot of formal stewards yet, data product owners. It's a new kind of role popping up, And there I see also with a lot of companies, they first start on the relational data side, on the IT side. So I think, to be honest, it's a journey for the operational OT side for the next years. It's a huge opportunity, I think, for the industry. But I think what's impossible is that all these companies will start to hire new people. So they have to do the transformation with the existing workforce. That means you need technology simple enough that people can change their job a little bit, that they also can be, for example, be a platform owner for the PI system, but also being a data steward, or I'm a citizen data scientist working with TrendMiner Seek, and I'm also like governing the data coming from the plant. So you will see hybrid roles. So you need technology simple enough but working that is enabling companies for this transformation, and not per se you need all these new roles.
But how do you exactly help customers with Timeseer? What does Timeseer exactly does?
Yeah. So positioning it in the stack, the OT, IoT landscape, first thing is, of course, connecting. Connecting can be linking it to data sets from data scientists, but also live systems like historians, cloud time series data storage, cloud warehouses, data factories, data hubs, all where data is today landed, right?
Yep.
And residing. So connecting, and the first step, Timeseer is profiling the data. So you're profiling what is sort of feature mining, statistics mining for all things that can be said about that time series data. What's in your data, answering that. We have like a couple of 200 basic checks to come up with relevant insights from profiling point of view. Step one. Step two is you need to make a thumbs up, thumbs down, like how good is this data I just profiled. So you're checking for quality, sort of a scoring algorithm. You can set your own scoring metrics by saying it needs to be 99% fresh, I cannot have missing values, sensors that are flatlining are a problem. So you're making a criteria, and then you score which names data validation, verification, but also contextualization is part of that. And that is the second step in, once the data has landed, you profiled it, and you're doing a thumbs up, thumbs down for a quality assessment, right? Once it's good, not good, your quality will evolve over time. So a third building block of Timeseer is you need to scan your data frequently. Like that's the data monitoring side. So your quality, scanning it per time. For an AI model, it can be that is per minute I need to scan for integrity problems. For an historian, maybe enough per week, per day. It's depending on the use case. After that monitoring, you see like if this data now is used in a data product somewhere, in an analytics product, or in your dashboards from analytics for industry, like an energy measurement, for example, and it has gaps, it has, for example, flatlining sensors, then you can decide if that to clean the data. So the cleaning is also a very important part of our observability solution, where you're taking the raw data, you're taking the data defects, and you're repairing them according to a couple of augmentation strategies. And augmentation strategies typically depend on the use case. So to give you two extreme examples. For an AI model, you don't want to impute hold last values, because that would be too of a bump. You would be imputing the most likely version. But for your report of energy, you would impute the most conservative value, because you're reporting on energy, right? And emissions. So the use case decides on the augmentation strategy. And that basically sums up Timeseer in 4 building blocks, like the connectivity, the profiling, the validation verification for thumbs up, thumbs down, the monitoring, and finally also the cleansing. And one last thing there, I see a lot of data quality solutions just stopping at the level of, you have a problem. No. We also go beyond it, and we repair your data to get it in a sort of a shape that you're using trusted, verified, quality data in your data products.
If I link that to what we call our data journey, where people start in the dark ages, they only have a SCADA system, then they go to initial visibility, they install an historian, for example, a PI system or whatever. Then they go to more a diagnose phase, where they are using those energy dashboards. And when they are really confident doing that, then they go to a predict phase and close the loop. if I compare that to what you are saying, and I think it's very interesting, is that also in Timeseer, you have these basic checks who just check for, I would say, is the system as a whole running as we should, or multiple systems, or my pipelines, are they running as they should? But once we go further in our data journey, we're going to use, I would say, use case-based applications where we say, okay, for this prediction model, we rely on measure A, B, and C to make it reliable. So is that
that's very right. We work with a sort of an onion model with complexity.
Yeah.
And the first level is indeed what you call the basic checks, where you're just checking for the fundamentals, like indeed duplicate timestamps, data not coming in anymore, so the volume, the lineage, that's all on like the basics. But then moving one level up, you enter the domain of what am I looking at? What kind of sensor is this or asset? And you're using indeed quality checks that are really relevant for that kind of measurement. If, for example, if I'm looking to temperature measurement and I see impossible jumps, you know this from the physics, right? You have the same with, for example, oscillations for certain measurements or like valves that are sticking. That are all attributes that are linked to more of the performance. And there you need to know what I'm looking at. And there is the whole thing. You're building up your quality layers. And the more you know what you're looking at and you go to use cases, the more specific you can get your quality rules. And that's also a big difference with, for example, horizontal quality approaches.
Something I hear quite often when I talk about that data journey, or if I compare it to your onion model, is people saying, yes, but we are not ready for this yet because of several reasons. Because we don't have an asset model yet, or we don't do data governance yet, or we don't have a cloud system yet. So I hear this, we are not ready yet argument quite a lot. Do people need to be very advanced in their data governance before they can start using Timeseer?
No, but it's important, again, that the burden of the proof is not only on us, right? Because if we need to convince data quality is important, you have to walk away, because the mindset is not there that data is an asset. The client is still in the mindset that with garbage data we can do it good enough. That means they are not there in their own journey. But if the client indeed, from a strategic level, decides data is the new oil, it needs to be governed and it needs to be one version of the truth as a starting point, then still a big bang, all data cleansing or governing is not working. That's why you start per use case. Then you're going to look to your critical assets, or you're going to look to your critical data products. Start there. And you start small, you increase, you build up. It's a plug-and-play platform that's very easy to use for lots of our partners. So there's no need for a big bang governing all my historians globally. It's the outcome eventually. You will see that. Like, I think a prediction 10 years from now, all sensor data out there will be checked for quality, because if it's stored, it should have a quality. Else, why would I'm storing it? But that's, I think, a 10-year plan. Companies can start now small, protecting their first vulnerable assets.
Yeah. I heard quite a lot of interesting things. You mentioned we don't need better models, we need better data. You mentioned that AI needs data quality, but data quality also needs AI, which I also remember. We talked about data platforms, where these OT and IT data platforms, they are merging, something we also like to refer as IT-OT convergence. And honestly, I think if we really talk about IT-OT convergence, it's about data. It's about data exchange from left to right and from right to left. So at Analytics for Industry, we are helping our customers to bridge that gap. We help them in building those scalable systems which are reliable. We also, as you mentioned, we want to eliminate manual work as much as possible, of course. And that's why we are partnering up with Timeseer. So today, we are very happy to announce to the market, to our customers, our partnership with you and your colleagues. So thank you for trusting us.
Thank you.
But maybe to wrap this up, Bert, one final question. So if any of our customers is watching this video, and they face similar problems, where should they start? How should they start?
Yeah. It's very important to answering your question is when they face problems. By means, if you're building like a new category, there's typically like a desire in the early days to convince people. And convincing means you're not aware or you're not convinced that quality is a problem. Those clients, you're too early. Probably they will be in the later majority when the market is further advanced. So you would be addressing clients from manufacturers or IoT companies that already are aware or convinced that their quality needs to be guaranteed, that they have a quality problem. Those are the clients where we focus on, right? That's the first part of it. Okay, so you're aware, you know you have a problem. The first thing is, how big is my problem? What we have developed, built on our platform is a sort of a vulnerability scanning or scoring and assessment where all clients that install Timeseer, it can be with uploaded data or like connected to live systems, can, together with our partners, analyze how vulnerable they are for quality defects linked to their operations, but also linked to their data products. Yeah. And that's a very first good step because then you see how vulnerable am I? And that builds typically the foundation block or like the business case for everything that follows. And the next step is then typically, if you know how vulnerable, you want to start protecting your data assets or your data products. But typically what you see is you don't start with a big bang project because nobody has time. You want to start where it hurts the most, and that is with your most vulnerable data product.
You also don't want to be flooded by those thousands or maybe 10,000 alarms. All right, so I would say to our clients, we would be very, very happy to discuss these challenges with you. So feel free to reach out to us. Bert, thank you very, very much for your time today.
Welcome. Thank you, David.
And well, let's hope that we can improve data quality and operational data platforms in the future together.
Hope is not a strategy.
Thank you very much.